We're up to 42 participants here. And there is an active chat.
Okay, it's 10:30, so let's begin. First, before I go through the usual note we need a minute taker. So looking for volunteers. Usually we would also have a Jabberscribe, but I'm not sure we really need one. So if we have a minute taker, that's grand. So if somebody wants to step up. I'll let you guys sit on that until I finish the note well. So I'm just going to show a few slides, the IETF note well. If you want to have a copy of these, they're all in the meeting materials, and you can download the full chair slides.
Let's see.
The chair slides.
Sorry, go ahead.
I was just going to say, we do need a minute taker before we proceed after this point. So we need to have a volunteer to. Should be fairly straightforward. They don't have to be extremely detailed, but we do need a minute taker.
Maybe Kiriti could do it. Kiriti, could you do it?
But
sorry, say that again.
I'll be in and out. I have a couple of other things to do, but as long as I'm in, I can take it. Is this on Ether, whatever, something, or CodeMD?
There's a link to note-taking tools, but if there's a volunteer who is present for the whole meeting, that would be best. Just scroll through the attendees.
Yeah, I'm looking for names I know, people I know well.
Well, it's an hour. I can take minutes. Just point me to where I should go for the.
There's in the top right. There's a note-taking tool of your window.
Top right.
On my view,
okay.
which should be the same, there are 2, 4, 6, 8, 10 icons, and it's the fourth from the left.
Well, it's slightly different in mine, but I found it. So okay. I'm not allowed access. Oh,
you have to click sign in, and I'll just have to allow permissions for. Yeah, if you click sign in, it'll just ask your permissions for the data tracker.
Okay, I think I'm in.
Okay. Cool. Like I said, we can proceed. Thanks a lot, Kiriti. It's appreciated. Okay. So today, it's only an hour. I've got a very small agenda. There's some administrative, like the note that we just did, and we gonna do a bit of an RG status. Then there's Qirg is going to present the use case draft. Gonna have a discussion on usually the usual open floor, just open discussion, questions, proposal for discussion, and what we could center it around is the architecture position paper that Rod emailed to the mailing list. And at the end, I'm going to also announce the next seminar that we have scheduled for September. So the current document status is that the principal's draft is actually not present for the agenda for this meeting because it's currently under IRSG review. Shepherd write-up was completed by David Oren, so I'd like to thank him a lot for that. We'll be discussing the use case draft today. Hopefully it's nearing completion. We'll see after today. I've had a look at the update. And as usual, we keep reminding people that there's 3 expired drafts because every now and then somebody comes to the mailing list and asks about it. No other reason. I'm going to leave this for later. So that's about it. So I'm going to leave the floor to Qirg then. Qirg, are you ready to present? You asked to share your screen, so I'm going to allow you, Qirg. Oh, I have to stop sharing mine, I guess.
Hi, Patek.
Hello, Qirg.
So can you see my screen?
I can, yes.
And I'm changing the slide. You can see them also. Okay?
Can see what?
I'm changing the slide. You also see the
oh no, I don't see your slides changing. I'm still seeing the title slide.
Okay. Okay.
What looks like your keynote screen on the. So if you're actually in presentation mode, we're not seeing the presentation mode. We're only seeing your editor screen.
Yeah. Okay. Maybe I try again.
Some advice from one of the other working groups: if when you are sharing, if you select an application, it then decides which window to show you. But if you pick a screen on the desktop screen, it should be a little bit more amenable. However, we are now seeing the slides.
Thanks, Tom.
And now?
Yes,
now
I can see it.
See my,
yes, and I started
changing
yes.
it now. Okay, good.
Yes.
So, perfect. Okay, so thanks, Wojtek, and hi everyone. So I'm Qirg. So today I'll be talking about the draft on this application and use cases for the quantum internet. So I joined this this project like few weeks ago, and most of the work was done by like Shongen, Akbar, Ridong, Melchior. I hope I pronounced the name properly. So let's see what we have been doing for the last few months. So this is like a small background. Like on version 4 was presented like during this IETF 110 on March 10th. And then we had like lots of comments, and then that's why like the authors like they prepared the version 5, and it was uploaded on March 29th. And then they prepared like version 6 where they include the first Byzantine negotiation, and it was uploaded in May 3rd. And the version 7, actually the current version was uploaded on July 12th, and now we are presenting it, and we'll show like what are the updates here. So the most update like was like, okay, I joined in that draft as a co-author, and then we added like 3 application examples like quantum money, quantum imaging, and quantum chemistry. We try to be fair for each of the domain of this quantum technology. Like quantum money is an application for quantum internet, quantum imaging mostly is an application for quantum metrology, and and quantum chemistry is more related to the quantum computing. So then we added also some new definitions, like some for some terms like EPR pairs, entanglement swapping, and quantum teleportation, because those are the very essential terms we need if we want to understand the basic principle of untrusted quantum repeater networks. And then we also made some editorial changes and improvements throughout the document. Okay, so these are the bullet points, and now let's have a little bit closer look. What are the updates? So on the right-hand side, you see all these red points. They are like the sections where we mostly made the updates. For example, in section 2, we added those new definitions. And in section 3, for example, in section 3.2.1, 3.2.2, and 3.2.3, we added the new applications of the quantum network, like quantum money, quantum imaging, and quantum chemistry. And in section 4, more specifically like section 4.1, we added the description about measurement device independent QKD and continuous variable QKD. Those are the two variants of the original quantum key distribution protocol that with a high probability it will be like those two technologies will be very popular in the near future for the implementation. And then we also made some other further changes in section 5. So today I'll be just going through all the section 2 and 3 and 4. I'll not talk about those small changes we made in section 5. Okay, so let's start with section 2. So in page 4, we added the definition of EPR pair. So let's talk about like what it is. So basically it's a, in layman term, it's a special type of 2 qubits quantum state. It's a pair of quantum state which looks like, one of them looks like this. It's like 1 by 2, 2, 0, 0 plus 1, 1. You can consider 4 orthogonal. It's like the EPR pairs are like 4 orthogonal states. All of them are orthogonal to this state. And so what's the like interesting fact about is that like those 2 qubits, they have some kind of special correlation that cannot be observed in the classical information theory. And it turns out that this kind of special correlation can be a very useful or maybe a crucial point or crucial resource for quantum communication and quantum computing. And most of the time, although it's not exactly clear, but it's a strong belief that this kind of correlation gives us quantum advantage over the classical one. Okay, so then let's talk about something called entanglement swapping. We also added this definition in page 4. So it's a very interesting tool or like a process for sharing entanglement between 2 distant parties via some intermediate nodes. Suppose we have like 2 EPR pairs, let's say AB and CD, where A and D, they are a bit distant party, and B and C, they are sitting on the same lab, and A want to share an EPR pair with 2D. A cannot send directly one part of the EPR pair to D, maybe because the distance between A and D is long. So what they can do, they can share this EPR pair with some intermediate party, let's say B and C, who are very close to each other. And then B and C they can do? They can perform some measurement called Bell-state measurement. And if it is successful, then the correlation between A, B, C, D will be destroyed. And there will be a correlation between B, C, and there will be a correlation between A and D. So that means like if the Bell-state measurement is successful, A and D will share an EPR pair. And that's a very basic tool for the untrusted quantum repeater technology. So we use this kind of entanglement swapping operation to create an EPR pair between 2 distant end nodes. Okay. So then we added also another definition called quantum teleportation. So this is also a very important tool for the untrusted quantum repeater networks. So it's a technique for transferring quantum information via local operations and classical communications. So it means that if I want to send a qubit, data qubit to a distant party, instead of sending it physically through the quantum communication channel, I can just use some kind of local operation and classical communication. So more precisely, suppose Alice and Bob, they share an EPR pair which looks like this. and Alice wants to send a qubit psi, unknown qubit psi, to Bob. To do this, like what Alice can do, Alice can perform the Bell state measurement, the same kind of measurement we have seen in this entanglement swapping operation. So after the measurement, what will happen? The correlation between Alice and Bob will be gone, and Alice will get some measurement outcome sigma, and Bob will instantly get the state like sigma of psi, but he will not have any information about the sigma. Sigma is like a unitary operator. We call them Pauli operator. And to get the psi back from sigma of psi, what Alice needs to do, Alice needs to send this classical sigma to Bob, and from there Bob can retrieve the state psi. So you see, like here we don't send the psi physically through the communication channel. Okay, so this is also the tool we use in this untrusted quantum repeater network. Okay, now let's focus on the application in section 2. Section 3. In section 3.2.1, we add like an application for quantum cryptography. It's called quantum money. So quantum money is like one of the first discovered applications for quantum information theory. It was discovered before even BB84. So because the idea was that, like, intuitively at that time there's no cloning theorem, I think. Yeah. So the intuition was that if we are given a single qubit, we cannot create a copy of it. So that's a perfect candidate for creating a banknote, because you cannot forge those notes. But the problem during that time was that, like, okay, no one could create a copy, but even no one could verify those banknotes. So that's why that idea was not that popular. But very recently, there are like more sophisticated protocols, like it's called public key quantum money and everything, where anyone can verify the banknotes locally. But so the security is like under some kind of computationally bounded adversary. Okay, so that's a very interesting application for quantum cryptography. And then we added another application for quantum sensor. It's called quantum imaging. So here what we can do, like, is a network of quantum sensors actually can measure the magnetic field generated by the flow of current through some neural assemblies in the brain while the subject is moving. And this kind of thing we cannot do using the current day classical strategies. So, and then because of that, actually it can reveal the dynamics of the networks of neurons inside the human brain on a millisecond time scale. So it's showing us a huge potential for the application. So this is like one example. Like there are plenty of other quantum sensor applications. So we just pointed out some of them in the draft. And then we choose an application for quantum chemistry. So here the main idea is that, like, we use quantum algorithm to somehow determine the molecular energies of the small molecules in the chemical accuracy. So the interesting part is that to implement such algorithms, we don't need a full scale quantum computer with the NISC devices like these near-term quantum devices. We can realize those things. Of course, for a very small number of molecules. But if we want to increase the number of molecules, then we need a bigger computer. But at least they are like a proper applications for the near-term quantum computers. Okay, so these are the major applications. Now let's focus again about the main applications of the quantum internet, is like quantum key distribution. So we all know that quantum key distribution can offer us security in this information theoretic sense. It means it's some kind of holy grail. We cannot have a secrecy more than that, better than that. But the problem is that all of those things are in pen and paper. So if you come to the practice, like if you want to build those things, all the measurement devices, all the like detectors, they have the flaw. And by exploiting those flaws, like people in first, I think in 2009, the people like come up with the like a side channel attack on the commercial QKD devices. They call like quantum hackers. So after that, like people are thinking, okay, so how to mitigate these kind of side channel attacks? One possible way to avoid the side channel attacks which are coming from the detectors is like this measurement device independent QKD. Okay, So using this kind of protocol, you can even if like the attacker, if you use this kind of protocol, and even if the attacker tries to manipulate the detector, then also they will not be able to generate the key or guess the key which is shared by Alice and Bob after the successfully completing the protocol. So that's a good advantage. So there are like more sophisticated version of this measurement device independent protocol. It's called device independent quantum key distribution, where you don't, Alice and Bob doesn't need to trust any of their like hardware devices. But these things are a bit away from the practical implementation, whereas this measurement device independent QKD, there are like many experimental demonstration for them. So another protocol which I would like to, one other version of the QKD or like QKD technology we added here in page 13 is called continuous variable QKD. It's comparatively new technology. So where instead of sending like a discrete quantum state, here what we do, we send Gaussian modulated like coherent state. And so the advantage is that like you can use the classical communication technology right away for this kind of continuous variable QKD. So it's a very engineering friendly and implementation friendly, but the problem is that unlike the discrete variable QKD, here the security proofs and everything, they are not that mature, but the community is working very hard. Like maybe in a couple of years we will have very concrete security analysis, and it can be used for in practice. So mostly it's okay. Another disadvantage for this one is that like we still don't have a quantum repeater for them, but they are good for short distance communication, even also for the free space communications. Okay, so these are all these updates, and let's now talk about what are the next steps. So this is our version 7, and it seems that it's a bit stable. And we also, it's stable because we take into account all kind of comments we get from this IETF 109 and IETF 110. And yeah, we are still waiting for new comments. If there is not enough comment, then it's stable, and then we can check whether it's ready for the last call or not. So thanks.
Thanks, Kaushik. I see there's already a question in the queue. Robin?
Yeah, thanks, Wojciech. And thank you, Kaushik. That was really interesting. I just have a one-word suggestion, and it relates to section 3.2.2 of the draft. So quantum sensor applications. I wondered if you had, because you used the word metrology when you were introducing the deck, and I wondered if you would consider replacing quantum sensor applications with quantum metrology applications.
Well, yeah, I think we. I mean, yeah. Okay, I agree with you. Yes.
The simple reason being it wouldn't exclude any of the use cases that you're looking at, but it would also give the opportunity to include specifically time quantum clocks, which I think are another really interesting metrology application.
Yeah, I think in fact we have the quantum like clock synchronization application in that section, but it was like, yeah, I agree that we should rename it to quantum metrology.
Thanks. You're way ahead of me. Thanks again.
Thanks, Robin. Any other questions?
Just a comment on that one. The metrology versus sensors. I have for several years been using the term sensors very broadly to include metrology and clock synchronization and things like that, including in some of the papers we've published. Metrology might be, I'm not sure. To me, metrology is actually more specific than sensors. Robin, do you think of metrology as being the broader term?
I kind of do, because, well, the session I was in, they described quantum clocks as a subset of their metrology work, whereas I wouldn't typically think of a clock as a sensor, if that makes sense.
I think of. Go ahead.
We can actually keep both of them, like sensor or oblique, like metrology applications.
I mean, I'm not not religious about this. It's entirely up to you.
I might be sort of misinterpreting it since I'm not in metrology, but I kind of think of metrology as being more focused on developing standards and measuring universal constants to high precision and things like that, as opposed to in the field working uses of those concepts.
Okay. It may in that case just have it may just have been a different taxonomy in use by what was actually, I mean, it was specifically a UK group of academics, and maybe they just have a slightly different taxonomy. Qirg is probably much better placed to gauge that than I am. It was focusing on Bristol, Edinburgh, and elsewhere.
Yeah, I'm willing to defer on that one.
Yeah, I mean, usually what I saw, like whenever they talk about this kind of sensing application, they try to measure the magnetic field related to something. So yeah, but okay, but I will have a look actually. So usually here we call them like metrology applications. So maybe I will have a look closely, and then we'll update accordingly.
Thanks for the question. Kiriti, you were briefly in the queue. Is there still a question you want to ask, or?
Basically, I think Robin's point is to include all the applications. Now, you can choose a name that is more inclusive, but let's just include the applications and then pick a name that everyone's okay with.
Yeah, I agree with that sentiment. I have one question for you, Qirg, which is, if you're adding quantum money, one of the obvious things to at least contrast this by saying is, how does it compare to cryptocurrency? Is there value in quantum money now that cryptocurrency is a thing?
Okay. So you mean the
Bitcoin? Yes.
So yeah, here we are talking about physical money, right? So.
Quantum money is physical money.
Yeah, I mean, so other than where you exploit the no cloning theorem, that you cannot copy your qubit, something like that.
Right.
So I think this quantum cryptocurrency would be like something different than the current definition of quantum money. So
right.
Yeah. So I think it's a bit different. So yeah, I don't even know whether people are still working on them developing quantum cryptocurrency.
Right. I'm sure there. Okay. Any other questions? Rodney, you have a question, or did you just raise your hand?
Stick my hand up and just sort of jumping in and interfering like I usually do. I have a few comments on the draft, some that are directly related to what Qirg just presented, some of which aren't. One that's been on the back of my on the back burner for a long time, I haven't gotten around to mentioning, I don't think, is this draft uses the term EPR pair, but Wojtek's architectural principles draft uses the term belt pair. And I think as QRG, we would be best off in picking one consistent term. And in this case, I think we've already sort of settled on belt pair. Belt pair has the advantage that it's easier to talk about Bell states as a basis set should we need to, and things like that, as opposed to EPR being sort of the, it's nice to pay tribute to Einstein and company for coming up with the idea, but the more mathematical form of Bell's approach is more useful in an engineering sense, I think.
Mhm.
So that's one comment.
Sorry, and based on the comment in the chat from Robin, it actually seems there may be some people confused as to whether EPR pair is the same thing as a Bell pair. So just to clear that up, yes, EPR pair is the same thing as Bell pair. Same thing as entangled pair. There's lots of names floating around for them. Anything that's to do with the quantum internet and pair is most likely a Bell pair.
So to expand on that just a little bit, Einstein, Podolsky, and Rosen wrote a paper in 1935, I think, pointing out that there appears to be this sort of non-local correlation in quantum mechanics, and therefore this was one of the things that sort of bugged Einstein about quantum mechanics, whether or not it was actually complete and correct and whatnot. But their paper was actually relatively qualitative and certainly doesn't use modern terminology and notation. But in the 1960s, John Bell said, you know, if Einstein's objection is really right, here's an actual experiment. Here's an actual mathematical way we could sit down and do it, and here's a term you could connect to doing it. And and part of what he defined is now called Bell pairs, and you can actually also use them as a basis set for actually discussing all 2-qubit states, just like you could talk about combinations of 0, 0, 0, 1, 1, 0, and 1, 1. So in the engineering sense, it's more useful and more mathematically defined in a modern sense.
Also useful because people talk about a Bell state measurement and not about an EPR state measurement. So a Bell state measurement, as Kaushik mentioned, is a measurement in which you measure 2 qubits to see which of the 4 Bell states, which of the 4 Bell pairs you have.
I think Bell pairs are like more like a general. They talk about the centered correlation, where the EPR pair is mostly looks like exactly like this. So that's also like a Bell pair is more general sense.
Yeah. Great.
Well, that was one comment. I've got one or two others here. Let's see. So, Kaushik, you just mentioned that the MDI and CVQKD, you mentioned them. They're now added to the draft, and you said, oh, by the way, we don't really have a good way to do this over repeaters. I don't think that's in the draft, and it should be.
Okay. So you mean the comment like, okay, so that we don't know how to do it over the repeaters, that part?
Yeah, because we're particularly for CV, because repeaters are they're essentially digital, abstracted away digital level stuff, and whereas CV is it's literally continuous variable stuff. So I don't know how you do that over Bell pairs. MDI also is sort of a physical level concept as opposed to end-to-end, abstracted away at sort of the digital level, right? That maybe a little less so. Those are the two comments I had at the moment.
Okay.
Are there any other comments in the queue? To be honest, then next we're kind of running to the next point of discussion, but that's fine because it was open floor anyway. Are there any other comments? If not, I have one more. No, so I'll say my comment. So I read the draft, and I think it's not, especially now with Rodney's comments being essentially just clean up stuff, and all the comments being just clean up stuff. I think it's getting near. It's basically there. I did notice there's quite a few typos in the latest edits, though. Typos and just small things I'd improve. But I'll send that to the mailing list, to the list of what. But after those last, I think it's basically ready. I'm happy with the draft as it is, I think. So I think I'd be ready for RG last call, and comments are slowing down. So that's just my comment on that.
I've only skimmed the most recent draft. I'll try to give it a more thorough read in the next week or so.
Yeah. Diego, you have something to say? I cannot hear you.
This thing asks you for permission every time you try to talk or to be seen. No, it's just a thought looking at what Qirg has been presenting and how the document has evolved. I was just wondering whether calling it use cases is a little bit limited, because it has to be more about, I don't know how to call it, application scenarios or something like that. It goes beyond a collection of concrete use cases. Simply that. It's not that I'm pretty happy with how the document is, but might be that if we want to, in the future, when this goes further and people may be interested in having a look at the documents, probably use cases is a little bit limited. That's all. Just something for reflection when we go on the last call, and just to open it and to make you think about it. Not that I have a concrete proposal, but
I'll make sure to include that as a question when sending out the RG last call or before that.
Okay.
Thanks. Okay, thanks, Kaushik.
Thank you.
Cool. So the next point on the agenda was open floor discussion. We tend to always have, and there always seems to be enough to discuss when people ask questions that we do actually fill up the time. This time, I suggested, and Rodney and I suggested to add a point about the mail, the architectural paper. What was it called? The architectural position paper that Rodney sent out some time ago. So if there's any questions about it or discussion to be had, because there was one on the mailing list some time ago, it's a good time for you to ask questions. Any clarity about that, or Rodney to just ask questions to the floor. So Rodney, do you want to take this?
Let me preface this with a couple of comments on the. So the primary discussion on the mailing list was between Alex and Joe Touch. I'm not sure if either of them is actually here today. I didn't see them on the attendee list last I looked. I was not totally ignoring the conversation going on about that, but I didn't feel the need to step in because Joe's replies I thought were actually pretty good. Joe and I actually agreed on a lot of things. That blog posting was put together sort of in response to, well, not particularly in response, but it has become time to start thinking about all of the pieces that are required for complete architecture and to start putting one together. And my research group over the last almost 15 years has worked at different parts of it. We worked at the recursion, which we think is the right approach for doing quantum internetworking. We've worked on how nodes communicate about what the sequence of operations is that they ought to be executing, which we call the rule set based approach. We've worked on routing. Most recently, we've worked on security. And so it seems like it's time to start putting all of that together. And I will say we're actually in the process of starting from that blog post and actually turning it into a full-scale actual research paper to be submitted to one of the top networking conferences with a deadline coming up. But even on top of that, whether that's accepted to the conference or not, on down the road, it seems like working on similar areas in QIRG is probably a good way to go forward from here. And so if people have either comments on the technical content of that particular blog posting or the discussions in the mailing list, or want to discuss whether or not that's the kind of direction we want to take QIRG in going forward, I'm open to discussion on all of that.
So are there any questions from the floor based on that email chain / position paper? I have one comment, which is that I like the rule set based approach. I call it under a different name. That's more familiar to the classical networking audience, which is match and action.
Yeah.
I like that approach because, yeah, it's good. And it's a good foundation for actually building up a functional control plane, etc. So also just to make this link for the audience, when Rodney says rule set based approach, it's based on a condition plus action clauses, which you can just replace the name condition with the name for match, and you get the same thing.
Yeah, so it's much like a software-defined networking architecture, except that we're viewing it as the rule sets as being constructed and distributed in a distributed fashion rather than depending on a single centralized controller. So we think this will actually work across a global internet, and we also think it will work reasonably well with the actual recursive architecture, which is the other sort of key element of what we're proposing. But my group is actually, we're actively working right now on a lot of the details of how the rule sets actually interact with each other, and trying to figure out issues like how you manage resources inside a quantum repeater. How many are you going to are you going to assign this set of qubits to connection A and that set of qubits to connection B? How do you deal with synchronization issues? How do you avoid deadlock? How do you maximize the autonomy of the nodes and minimize the number of round trip or one-way latency weights and things of that issue without having without potentially sacrificing correctness. So all of those kinds of issues are exactly the kinds of things where QIRG participants really have the expertise, because particularly for these 1G networks, the first generation of networks using the entanglement swapping and purification, they're very much a distributed computation. Building end-to-end entanglement involves actions and decision making at nodes all along the path. So actually doing that level of distributed computation, that's something the physicists are not good at, and the people in IETF and IRTF are good at. And so that's the kind of thing where we would like to have more contribution from the QIRG community. Yeah, Greedy?
The term purification, is that the same as distillation?
Yeah. Again, there's one where we probably ought to pick one term and use it. The Wojtek tends to use distillation, and I tend to use purification, and we really probably ought to standardize on one term. They actually have a slightly different algebraic meaning, but I'm not enough of a mathematical physicist to sort of keep them straight. Wojtek, any other comments on that?
Yes, so I spent probably a day once figuring out which term to use, and I asked somebody who knows maths better than me, and they explained purification to me, and I did not understand it, and I went for distillation then. It's basically the long story short. Purification has some very particular meaning to do with interpreting quantum state in the context of a density matrix or something like that, and I think it actually is incorrect to use the term purification in the mathematical sense for when we mean what we mean in the quantum networks, but I am not 100% sure. Somebody with a better mathematical background than me would have to check. Kaushik is.
I did not create the term. I picked it up from somewhere else, and I think a lot of the early papers on the concept actually use the term purification when they're talking about using multiple entangled states to put together, to essentially perform tests on one entangled state and create and improve the fidelity of the end-to-end connection. But the postdoc in my group, Mikkel, is actually more of he's a theoretical physicist, and I think given a blank sheet of paper, I think he would probably lean toward the term distillation as well. He described to me once why he thinks that it's a more appropriate term, but the explanation was, I sort of nodded along, and then afterwards went, okay, I'm not sure I understand it, but I understand Mikkel's position.
Kaushik, you have something to add? Cannot hear you at the moment.
Go for the distillation term. So
Can you repeat what you said? Because I only just started hearing you.
Okay. So I think I mean I would also prefer distillation over purification. I think it's more appropriate in a sense that purification is somehow we say like, okay, if we have a density matrix representation of a qubit, like by purification we mean like, okay, we go to the larger Hilbert space and consider the pure state version of that density matrix. So in the distillation we somehow basically says, okay, here we have multiple pair pairs with or multiple state with low fidelity, and we want to distill the entanglement out of it. So it's just like, okay, that's why I prefer the distillation over purification. So yeah.
Cool, good question. Any other questions? Basic questions, as you can see, are fine, because whilst perhaps me, Rod, Kaushik, and a few others might understand what's going on, it's a good chance for us to actually make sure everybody's on the same page in the QIRG, especially to understand the context of the documents then. And so these questions are good.
Yeah, in Wojtek's draft on the architectural principles draft, section 4.4.3 error management, the first subsection of that is distillation, and it says through a process called distillation (parentheses), sometimes also referred to as purification (end parentheses). So I think we have sort of converged on the term distillation. I'll do my best to use distillation rather than purification, although a decade's habit is sort of hard to break.
So any other questions then? Colin.
Hello. Can you all hear me?
Yes.
Yes.
Yes. Good. Good. So I'm going to ask the really stupid question because I don't even pretend to understand anything about quantum internet. You know, you've got the principles draft, and you know, if I understand correctly, that's sketching out a set of concepts and ideas which you would expect different quantum, a quantum internet to obey. And this blog post is sketching out one concrete realization of those principles in a particular network. Is that right?
Yeah.
Yeah. Okay. So I assume we're still at the stage where it's likely that there will be other realizations of those principles which are presumably quite different, or potentially could be quite different. Yeah. Yeah.
In the end, we'll certainly need to converge on one internetworking architecture, but I fully expect that there will be multiple network architectures. And so far, ours is you know, despite over a decade's work, it's very embryonic, and yet it's still the only real internetworking proposal I know of, as opposed to network proposal. Lots and lots of people use the term quantum internet, but very few of them really understand what internetworking is as opposed to networking. And what we're aiming for, what my group is aiming for with that blog posting and our current work, is internetworking architecture.
Right. Okay. And there are testbeds which you can internet work.
There will be many different physical implementations for sure, and there will also be different philosophies for how to control those networks, and different philosophies for how to handle errors within those networks. And then those networks will certainly want to interconnect in the classical internetworking sense. And so something needs to happen at that boundary. We also we are proposing that our rule set based approach can actually be used all the way down to essentially the link level, but in an internetworking sense, it would not have to be. You know, if you want to do something different for your link and network architecture, that's fine, as long as at the boundary you can meet the right requirements for doing the internetworking.
Yeah. Okay.
I want to just add something about that test beds. So you mentioned test beds. Yes, so there are, because the United States have published this document about their, I think they call it blueprint as well. Then in Europe, there are demonstration networks being built. In fact, the Netherlands actually happened to allocate 650 million euros to quantum technology, and some of that is going to quantum networking and actually building. And this one's actually this is not just for pure research. This is also money to actually deploy real quantum technologies. So there will be concrete testbed networks popping up soon. So I can't say tomorrow, but this is now like somebody dumped a lot of money, so hopefully something will come out of that lot of money somewhere, some point.
Okay, so is this something where we are likely to see prototypes with the internet working in I mean, presumably not in the next sort of couple of months, but in the next sort of couple of years or something, or is that still 10 years out? So?
In fact, actually, let me just find you very quickly a link after I answer this, because actually it would be very good to share. Yes, the plan is to very much have within the next few years. I'm just trying to be careful that I only say what the public information is. And the plan is to actually have networks that are open to industry for use cases, to open to net researchers for researching protocols. The idea is to actually have networks open to people who want to use them and explore them. They're not meant to be closed off for us to just say, hey, we keep doing stuff here. No. They're very much meant to be open. When and how that happen, it's still ongoing work. But now that I've answered that, I'm going to go and find a link and post it in the chat.
Okay, great.
And
Thank you.
while you're doing that, Robin is also in the queue here, and we're down to just a few minutes left on our time schedule here. Robin?
Okay, is the mic live now?
Yeah.
Great. So yeah, thank you, Colin, because you've kind of given me permission to ask my own my own noob question. So following on from Colin's question, I think in all the QIRG sessions that I've been in, any quantum network has always had to be accompanied by a classical computing kind of control plane. So I guess one assumption when you come to the internetworking part is, are you going to have not just one set of interfaces between different quantum networks, but also a requirement for a second set of interfaces between the respective classical control planes for those networks?
Yeah, and in that sense, the work that we're primarily doing right now in that terminology would actually probably be control plane work rather than the actual data plane related work. Although when you talk about data plane, there's both the need for the actual physical photons and memories, photons flying around and memories sitting still, and and also sort of the low level control of that, which is still also ultimately classical control.
Yeah. And if there is time, but if there isn't, just ignore this. But if I don't ask you lot, who am I going to ask? So again, going to Colin's point about will there be different kind of approaches and philosophies behind different quantum networks? Might one of those be that in one quantum network you choose one particular entanglement property to measure, and in an adjacent quantum network the other guys might have chosen some completely different property of their pairs to measure? And so
yes, that's entirely possible.
So you'd both be measuring states between pairs of your own type, but then you might have to find some way of transferring or reflecting state from, yeah,
exactly.
Polarization. Okay, thank you. Good, I'm getting there.
Good. Wojtek, you want to make the announcement of the seminar before we lose people, and then we can.
Yeah, no, precisely. I was about to wrap up. Although Kiriti does have one more comment, so I'll let that one through. Kiriti, would you like to say something?
Yes. When Rodney said that, the connection between quantum and classical networks will primarily be in the control plane, that got me perking up, because I had written a draft on that, which is long expired, but that's more about sharing in an OSPF connection in a classical network that's adjacent to the quantum network, sharing properties of the nodes in the quantum network, like how many qubits, how many storage qubits, how many traveling qubits you have, and so on. I don't know if that, I don't know if people have had a chance to actually look at that, and if that's a foundation for at least some of the control plane work that reflects the quantum network in a classical network, so people can make useful decisions about how they want to create new entanglements or distill them or whatever. How should that, if I resurrect the draft, how should that go forward?
Do you have a comment first on that?
Not particularly. I was actually just looking for the expired draft, and I haven't pulled it up yet. But if you want to revive it, I would say by all means let's do it. But in light of the work we've done in the last almost 2 years in QIRG here, it might mean we might look at it and decide it either needs to be completely redone, or maybe we only need little tweaks. But we should look at it.
I'd look forward to a discussion around it myself. So I'm sorry for cutting Rodney, but we do have 4 minutes, and Vitek will cut us off. So I would see it interesting. I think the one issue is being a very practical draft. It would be cool to actually see something in action. But I don't know. Shoot an email on the mailing list. To be honest, I found it an interesting topic myself. So we'll see what.
Wojtek, do your seminar announcement before we lose people. We're going to lose people here momentarily.
Yeah. Okay. Thanks, Kiriti. So let me just quickly share my screen. This time.
Although there actually is a half-hour break after this, so people aren't running off to the next meeting. They're running off to chat.
So we have a seminar scheduled for the 22nd of September as a virtual interim of the QIRG. It's by Wolfgang Durr. So those of you who pay attention to academic literature, he's one of the co-authors on the original quantum repeater paper. All the information is in the link. That's shown below. If you want the link, you can always download the slides from the meeting materials and see it, or maybe somebody already posted it. So basically, we will announce it again at the QRG mailing list. It's actually already officially announced, but I will just keep sending reminders and a calendar event and everything. So, yeah, everybody's welcome. Hopefully, they have a good attendance, and hopefully, it'll be very interesting. Wolfgang said he'll be talking about control plane topics, which should be of interest to a lot of people in the QIRG. So that's it for the announcement. So, thanks, Kiriti, for taking the notes. That's really appreciated. I'll take care of collecting those, because they're in Cody. I'll just take the notes from there and email them to the mailing list. So I think you can actually just stop there. Yeah, so thanks, Kiriti.
Let's see. Yeah. So November? September. Has November been announced as all online yet, or are we still thinking about doing this in person?
You mean the next IETF?
Yeah. Mm-hmm.
No, the next IETF will probably be online. I don't know.
That decision is being made next week.
Okay. Hope to see you all in November. It would be nice to do it face to face, but if not, we'll probably do another session sort of like this, where we sort of run through the drafts and sort of work, pretty direct working stuff on it.
If we're not doing it face to face, can we just teleport?
Hopefully, that'd be nice.
Yeah. Cool.
All right.
Okay. Thanks, everybody.
On the meeting end in November, and in the September seminar. The seminar should be good. Please come.
Yes. Thanks.
Okay. Thanks.
Okay. Bye, everybody.
Thanks, Hugo. Bye-bye.
That went reasonably well, I think.
Yeah. I'm curious if we do want that November session. So I remember you saying that we should have a session, an online session, whilst the pandemic is ongoing. But it seems that the sessions will be online for years to come. So trying to manage this breakneck pace of 3 meetings a year is quite hard.
I
So
know, but
we have
yeah,
material.
because the IETF and IRTF are really composed primarily of professionals for whom the focus of what gets discussed at the meetings is really their full-time day job, and for me that serves as incentive to try to keep up.
Yes, I mean I remember when I was,
otherwise my life goes into, I've spent the last I was thinking last night in sort of a depressed fashion, where has the last 4 months gone? But
yes.
otherwise it's just all of the day-to-day distractions.
Yeah. No, we'll see
All
if
right.
there's material. It would be good to actually get the use cases, application scenarios draft, or use cases drafts they're called.
Yeah, and it's getting better. It's getting better.
Yes. So, yeah. Okay then. I'll let you go, Rodney, and I just
It's
stay back
now
to.
exactly an hour.
Yeah, I think they make me take our room, stay around for 10 minutes because people complained about getting cut off on the clock. Unsurprisingly.
All right, see you.
Yeah, see you around.
Stay safe,
Bye.
everybody.